Okay, so let's talk about something called heat capacity. So all substances have a defined heat capacity. On slide number 39 of your lecture, there is a list of different heat capacities of different substances. So essentially what a specific heat capacity is, sometimes you'll hear heat capacity called specific heat. It's abbreviated in your textbook as CP, that's a subscript P. And what the specific heat capacity is it's the quantity of heat needed to raise the temperature of 1 gram of a substance by 1 degree Celsius at constant pressure. So it's specific heat. The specific heat is specific to the substance, meaning the specific heat of iron is different than the specific heat of aluminum, or the specific heat of lead, or the specific heat of water. Every substance has its own specific heat. So when you're dealing with one of these problems where you're calculating the heat of a reaction using specific heat, you'll need to either be given the specific heat of that substance, or you would look it up in a table, like the one on slide 39 of your PowerPoint lecture. So the formula for using specific heat, if you're given, if you're doing specific heat, the formula is Q, heat, equals specific heat, or mass of the substance, times the specific heat of the substance, times the change in temperature. So this is the mass in grams. The specific heat is going to be given to you in a unit of joules per gram degree Celsius. And then the temperature will be a change in temperature. Remember that triangle there means change in, will be in degrees Celsius. So remember, change in temperature, anytime you see this triangle, means change in. This is the same as saying final minus initial. So for example, if the temperature went from 75 degrees Celsius to 100 degrees Celsius, the change in temperature would be final minus initial. 100 degrees Celsius minus 75 degrees Celsius would be 25 degrees Celsius. That would be the change in temperature. So it's final minus initial is how we calculate change in temperature. So this specific heat is going to be in joules per gram degree Celsius. You'll need the mass. There's another version of this using what's called heat capacity. Heat capacity uses the molar heat capacity, where this is in moles. So then your molar heat capacity would be in joules per mole degree Celsius. That's another version of this that you might see, but this is the one that we will most commonly use. You'll know which version of the formula to use based on what specific heat you're given. So for example, the specific heat has a unit of joules per gram degree Celsius. You know you're going to need a mass in grams. So let's look at an example. A lot of these types of reactions like that we are going to be talking about right now are going to take place in something called a calorimeter. A calorimeter, you'll talk about this in one of your labs coming up soon. It's measuring calories. Calories are just a unit of energy. It's a device used to measure heat that's absorbed or evolved during a physical chemical change. So it's measuring heat. So you'll see a lot of these reactions, it'll say that this reaction was placed in a calorimeter. That just means it was placed in a device that allowed for us to measure the change in heat during this chemical reaction. Okay, so let's look at an example. So I'll write this out. It says a piece of zinc weighing 35.8 grams was heated from 20 degrees Celsius to 8 degrees Celsius. .8 grams was heated from 20 degrees Celsius to 28 degrees Celsius. How much heat was required? And then also given to you would be the specific heat of zinc, or you would look it up. The specific heat of zinc is 0.388 joules per gram degree Celsius. So the question is asking how much heat was required. So there's a few clues here as to what's happening. So the piece of zinc was weighed, and it was heated from 20 to 28. So you're putting energy in. So this is going to be an endothermic reaction. You're adding heat. So this is going to be a positive enthalpy change, or a positive Q, a positive heat. So let's put this into our equation. So our equation is Q equals mass times specific heat times change in temperature. So Q is what we're looking for. Mass is going to be 35.8 grams. Specific heat is going to be 0.388 joules per gram degree Celsius. Change in temperature, final minus initial, is going to be 28 minus 20. It's going to be 8.00 degrees Celsius. The change in temperature also tells you the sign of this, because you're increasing the temperature, you're adding heat. So this is endothermic, because it's not the zinc that's giving off the heat, you're adding the heat. So Q is going to be 35.8 times 0.388 times 8. Grams are going to cancel, degrees Celsius are going to cancel. Your answer is going to be in joules. Q is going to be 111 joules. That's how much heat is required. That's how much energy you have to put in 35.8 grams of zinc to increase the temperature of that zinc from 20 to 28. This is a positive number. It's an endothermic reaction. This is the amount of heat that it would take to do that process. So let's look at another one. Not that one. So for these heats, specific heats, all you need are the mass and the change in temperature. So another thing that we are going to talk about that we can use to measure heats of reaction are two special types of enthalpy changes, and that's called the enthalpy of fusion and the enthalpy of vaporization. They're called the heats of fusion and the heats of vaporization. So the heat of fusion is a special energy when you're going from a solid to a liquid. Heats of fusion and the heat of vaporization. So this is no longer about heat capacity. This is on to heat of fusion and heat of vaporization. So the heat of fusion is a special amount of energy that it takes to change state. So here we're only changing temperature. Here in these two we're changing state. So this is the amount of energy required to change state between a solid and a liquid. And you could go either between a solid and a liquid or a liquid to a solid. It would just depend which way you were going for the sign to be positive or negative. The heat of vaporization is the amount of energy